All right, welcome everyone. Let's go ahead and begin today's session. Hope you're each having a great day. Thank you so much for taking the time to join us. My name is Colleen Berry. I'm the Marketing Director for Burwood Group, and I will be your host for today's webinar. Let's dive right into the topic, which today's topic, our third in our four-part series, is Roadmap to Modernization, your guide to building cloud-native applications. Burwood Group is thrilled to partner with Prime TSR on today's session. Just a little bit about us. Burwood is an IT consulting and integration firm headquartered in Chicago with offices and employees across the U.S., and we help our clients leverage the cloud to transform their IT infrastructure environments. And with Prime TSR today, an expert themselves in digital transformation, cloud, and IT strategy, we've planned a very detailed and educational session, really a step-by-step journey towards application modernization that you can follow in your organization. So as I said, I just want to remind everyone that today's webinar is the third of a four-part series on application modernization using Google Cloud. You can see the details here from our past sessions as well as today and upcoming. If you enjoyed today's session, I can guarantee you will not want to miss our final. We'll dive into just continue the roadmap discussion towards application modernization for you. So please save that date on your calendar, August 19th. And if you missed either of the first two sessions, you can check them out on Burwood Group's YouTube channel. So just a few housekeeping items before we dive right in. We've allocated 1 hour for today's session. We are recording this. Recorded version of the webinar as well as the PowerPoint slides will be available and sent to all of you following today's session. If you have any questions throughout, please use the chat or QA window on the right side of your browser, and we'll get to as many as we can throughout and at the end of the session. So without further ado, let's go ahead and meet our presenters. I'd like to introduce Ed and Rich from the Burwood and Prime TSR team. They will introduce themselves and then dive right into the agenda. So gentlemen, please take it away.
Thanks, Colleen. Hey, everybody. Thanks for joining us this morning and this afternoon. We're excited to have everybody back for another modernization session. So I'm Ed Keene. I run the Cloud and DevOps group here at Burwood.
And I'm Rich Kopakin. I'm a lead cloud solutions architect for Prime TSR. And today we're going to be talking about, as Colleen said, the roadmap to modernization. And yes, this is a DeLorean that you're looking at from Back to the Future. And that's going to be part of our theme today, is really, I know some of you work on applications that are maybe 5, 10, 20 years old, and sometimes it feels like you need a time machine to get yourself from the past back into the future. And again, that's going to be our theme for today. So before we dive into it, though, we're going to go through a few poll questions just to learn a little bit about you guys. This first one is, what are you modernizing right now or looking at potentially modernizing? Again, as we talked about in our first session, you should always, always, always be modernizing something. If you're not, you're going to get left in the past and fade away. So, you know, here's your options. You could be even modernizing your DeLorean, but this is the first question, and feel free to pick multiple. And Colleen, if you want to go to the second one. Where are you running your workloads today? So, you know, we've looked at statistics, and 80 or 90%, I think, of corporate IT is already running on one or more clouds. That's why this is a multi-select. You know, we imagine that you're at least on one already. And if you're not, you know, we hope to be able to get you there quickly. So, Ed, you want to take it away on your backstory?
Yeah, a little bit more about Rich and I while we give everybody a couple of minutes to fill the polls out. They should have popped up on your screens. It should just take a minute to select all the relevant options and hit submit. So I mentioned I run the Cloud and DevOps group at Burwood. I've been here for 3 years, and then my background has been working for software companies, helping get software from developers' workstations through integration and ultimately running in production environments, and then making sure that it's performant, highly resilient, highly scalable in those production environments.
Yep. And so my background is in web development. I've been in the game for about 15 years, consulting for the last 10. I'm currently leading 2 of Prime TSR's practices, both our application development practice as well as our Google Cloud practice. about 4 years ago when I joined Prime TSR, they gave me they said, you'll have the opportunity to work on all the different clouds and all the different latest, greatest technologies. And I didn't necessarily 100% believe them at the time, but I've actually just been very, very fortunate and very lucky that it has turned out to be true. I've had a chance to work across all 3 major cloud platforms, Azure, AWS, Google Cloud, both doing architecture as well as hands-on work. So that's currently why I'm Prime TSR's lead cloud solution architect. My days now usually are spent doing enterprise architecture for some of our larger clients, and I just learn and consume everything that I possibly can about the Google Cloud and speak about it to everyone else. So hopefully that ate up enough time talking about my boring background to allow the polls to close and get our answers in. What do we got?
Yeah, so the polls should be closing momentarily, and then we have a look at the results. While we wait for them to close, let's get started. So we're looking to help everybody understand what do we mean by application modernization, and basically like getting into what does the future/present look like. So let's take a step forward. Application modernization probably means a lot of different things to a lot of different people. Specifically, what Rich and I are going to be talking about is some of the cloud native concepts. So this is where we're looking at building highly scalable applications that meet the demands of your flocking users and growing user base as well. They're scalable enough to handle huge volumes of data and stay performant and ultimately rock your users. And they're typically running in highly dynamic environments. So these dynamic, ever-evolving, growing environments as well that your application is built around in order to make the most of. So cloud native has other traits as well as being scalable, performant, dynamic environments. There's typically things like the use of containers here, and we'll talk more about what we mean by containers in a few minutes. As you start spinning up different services, there's the idea of service mesh and making sure your services are aware of each other and easily communicate with each other. Then there's a concept of the declarative nature. And so when we build things, we want to do so really with a blueprint or a template in a declarative nature, where I say, hey, I want 5 servers and this configuration and this networking and this application deployed in this state. And I define how I want it. And then the systems go off and build it. This isn't where I'm defining how to build it. The systems are doing that. I'm just saying what I want. And that's a declarative nature. That then allows me to build immutable applications as well. So rather than the old days of RDPing onto a Windows server to go troubleshoot an issue and change a configuration and keep changing stuff on the fly every day, where it becomes much harder to manage and understand what current state is. Instead, because we're using a declarative nature, our infrastructure and applications are immutable. So if I need to make a change, I'm going to make a change so in my declarative template and redeploy rather than changing what's already running in production.
Yeah, I know you're going to be talking a lot about the concept of infrastructure as code, which I love is just self-documenting its infrastructure. There's no questions out there. I'm sure you'll get into it later. Really quick, before I go into Greenfield projects, I see our polls closed and we got some results, and I was just looking at those. Interesting to what we're modernizing, the 2 biggest ones I see are both infrastructure and applications, and to me that absolutely makes sense, especially nowadays with the cloud. They really go hand in hand. There's a really blended line now between what your application architecture is and what your infrastructure architecture looks like, especially with cloud native services. And then I also saw that, a lot of people are still running on data centers as well as AWS and Azure. This actually pretty much works out to what the actual numbers are out there in terms of percentages of cloud adoption. It looks pretty spot on. Ed, anything else you notice that jumps out?
Yeah, I think yeah, it's interesting as well, seeing the trend of where workloads are running, like AWS being the front runner on the cloud side, followed closely thereafter by Azure, and again, followed a little bit further behind by Google. And this is the way that it's been over the last couple of years, but obviously with Google getting closer and closer as they invest more into the enterprise.
Yep, they're really up and coming. So yeah, to talk about to go on and talk about the greenfield versus other projects, we're talking about modernization, so obviously greenfield doesn't apply to this as much, but just wanted to highlight it that everyone seems to love greenfield, and there are some challenges in it as well, because there are a lot of unknowns. You have to build an entire environment yourself. Because there's so many unknowns, it really lends itself well to agile. That's the type of challenges you'll face when doing it. But you also have no legacy constraints. You're able to use the latest, greatest technologies without any roadblockers. But most of the projects that we all get faced with are, if we go to the next slide, the Brownfield projects. And these are the ones where you really have an opportunity and to grow, room for improvement. I know that everyone comes in and they're like, I don't want to have to read somebody's old spaghetti code. There's usually sometimes somebody who's been working on this application for the last 30 years and it's their baby and they know everything about it. And it's written in mainframe, and sometimes there's a little resistance to change there. But these are the two major types of projects that we face. You want to go on to the next slide?
When we look at Brownfield apps, there's some pretty typical traits that like Rich and I see across legacy or Brownfield applications. So the first being a tightly coupled monolithic architecture. We'll talk a little bit more as we go through this as to what some of the challenges are that come from there. But in summary, because everything is so tightly coupled and highly dependent, it all needs to be upgraded together. And so what ends up happening is you deal with bigger and bigger batches. And so you're dealing with longer release cycles. And then the releases are really scary as well. It's like, okay, we're going to need to take a 12 or 24-hour downtime window to go do this next release. And who knows what it's going to break. So then it requires some pretty heroic support efforts as well. And oftentimes what we've seen is people work around application performance constraints by just throwing more expensive hardware at it. It can be the quicker, easier, although often obviously more expensive option of mitigating application performance issues. As you get into the cloud, you really start to see the cost of those more expensive hardware as well. And that's when being able to change how you architect your applications and start using microservices is going to be a much nicer alternative to more expensive hardware.
Yeah, that's elastic scalability, absolutely. And I've seen that so many times that you mentioned it, where it's somebody's like, well, it's having performance problems. We're going to solve this with money. We're just going to throw money at the hardware until it performs right. And yeah, you end up for a gigantic bill for an application that really, if written well or architected well, should cost you. I've honestly seen some that are probably spending 100 times more what they need to on the hardware just because of bad code.
And you see like a lack of observability with logging and monitoring and not knowing if something's gone wrong, like what's gone wrong, and taking a long time to figure out the root cause. And candidly, like we see a lot of these are Microsoft-based solutions, like running in .NET framework. It's great that Microsoft is now moving forward to running on Linux, and with .NET Core moving to more microservices-based development. So things that we'll talk about. Things that we'll talk about on your roadmap to application modernization. So Rich and I are going to start with infrastructure as code, talk about the role of CI/CD, start containerizing some applications, then being able to do so in production and at scale with Kubernetes. We'll have a walkthrough of how to break apart your monolith into microservices, starting to write API-based services as well, and then being able to manage all the communications through like a messaging bus, and then ultimately operating your production applications now too. So to get started, one of my favorite topics, infrastructure as code. We wrap it up into infrastructure modernization. This is where we're looking at using tools like Terraform, Google's deployment manager, to declaratively write out our blueprint or our template for what our infrastructure wants to look like. With this then, it's kind of the foundation for infrastructure automation, where we can automate provisioning and tearing down of infrastructure. We can utilize like auto scaling and load balancers. And then we can even automate some things like DR as well. Hey, if we wanted to be able to spin up a DR workload very, very quickly and easily all through code. It doesn't need to stop at infrastructure. We can do pretty much everything as code. So as you build out your cloud environment, you look at your cloud projects in Google Cloud or your subscriptions in Azure, putting those into code as well. Doing your governance and policy in code as well. And then Terraform has over 150 providers, and so these include the ability to manage things like third-party applications like MySQL, even SaaS-based applications like PagerDuty and New Relic. So infrastructure as code that can get a little bit confusing. So what we're talking about here is, hey, you can template your infrastructure, template your VMs, package them all up with a tool like Packer. Then we're getting into like managing the infrastructure and provisioning the infrastructure. And this is where Terraform comes into play. And I'll talk a little bit more in a few minutes about that. Once you've got your infrastructure in place, that's when we can start configuring the operating system, installing any dependencies, then installing applications and performing like post-install changes as well. And this is where you would typically find something like maybe Terraform and an Ansible combination, or Terraform and Chef. Really,
yeah, I love this slide because I, as a software guy, used to get really confused as to these concepts. I mean, since the cloud now obviously it's blended, but people throw out Chef, Puppet, Ansible, Terraform. It's like, where does one start? Where does the other one begin? And yeah, it's so blended, but this makes it really clear. Oh, sorry, Ed, are you on mute?
I am indeed, yeah. Good catch, thanks, Rich. So it gets a little bit confusing because you can definitely use tools like Chef to provision your infrastructure, but we find for our customers and use cases like a better combination of using like Terraform for your infrastructure and Chef for your configuration management. Especially as we start building things like a cloud landing zone. So this ends up being like your reference architecture for building new cloud environments, like new cloud projects, new cloud networks. You're putting everything into code. It's all secured and governed. It's got ideal configuration, and hey, it's all automated as well. So there's a number of benefits from using a cloud landing zone and moving to this model of like an account vending machine. So where, hey, anytime somebody needs a new account or a new project, say in GCP or AWS, like we can have the automation to create the account, perform the account baseline, put in place our security and our permissions, set up the auditing and logging, all the networking. All of this can live in Terraform code and all happen through automation. So Terraform is the mechanism of communicating with the public APIs of like AWS and Azure and Google Cloud. So you need to just learn like one language, in this case, like the HashiCorp language. Looks fairly similar to YAML. It's very human readable, easy to read. You basically write your blueprint or template. Terraform then translates that and goes off and talks to AWS, Azure, or Google and builds your infrastructure. So in this case, we're building a network and a subnet. We can also build a Google project. We can also define and build organization policies as well. Whether it's in Azure or Google, Terraform is cloud agnostic. So it's very much our tool of choice for infrastructure as code.
Yeah, allows you to spin up those environments like that when you need a new one. Just had it on a project recently where it was, hey, we need another test environment because complications between this project and this project. All right, boom, it's there for you. Not less than a day's setup.
Exactly, and being able to do so consistently as well is key too.
Absolutely.
So we've got our infrastructure as code in place. We're starting to modernize our infrastructure. The next thing to have a look at is making sure that we have CI/CD in place. I'm not going to go into too much depth with what CI/CD is, but really what we're talking about here is planning, coding, building, so the integration of code from within your team and within across teams as well, and then automating the testing here too into your CI pipeline. Looking to do so in a cloud-native way. So what we're looking at here is using more modern CI tooling to really move to like a SaaS model for CI. So where you're no longer having to manage like the Jenkins servers on premise, all the Jenkins plugins. This is going to allow you to run more frequent builds and also faster builds as well, more scalable, faster builds. It provides some compliance and security in here as well. And then ultimately, it's going to provide ease of use and reduce like your CI complexity. Allow people to get set up and running much quicker and easier with building CI pipelines.
And these are definitely foundational to me as well. Both the obviously the infrastructure and the CI/CD. Those are two things before you even start moving to the cloud. Your applications you really want to have in place because this is going to save you so much time later on. Again, we're on a road to doing it. This is the first part of your journey.
Yep. And then one of my favorites is moving to cloud native CD, where you have more knobs and levers for how you manage your deployments. So a lot of the tools in the cloud native CD world are cloud agnostic, so it doesn't matter whether you're provisioning on GKE, EKS, AKS, any way you want to. They provide great capabilities around like canary and blue-green deployments as well. And we'll talk more about that in the next session too. Simplified rollbacks, more granular pipeline control, deployment security, and then ultimately, as you look to run more Kubernetes in your run more applications on Kubernetes, then it's going to give you more granular control over managing your Kubernetes deployments as well. So here's an example of our cloud-native CI/CD pipeline. So we've got our developer committing the change. We're doing frequent incremental commits. Hey, our good friend Jenkins here is doing our automated merge, our lint, static analysis testing, unit testing, and then ultimately the build. We're going to go run through and do our deploy where our functional testing is going to happen. Then, hey, once that functional testing passed, then it's going to be automatic promotion. And then this is where we've now got our gatekeepers and our safe rollout strategy and our release management through to production as well. So as you mature and become more confident with the tooling and the process, then this is the part that you can look on how can you start automating these checks and balances for your promotion and production as well. Talk with Spinnaker that we'll dig into a little bit deeper in the next session as well. This is a great tool for being able to do CD for Kubernetes. So now containers, Rich.
Oh, yeah. So really quick, I saw Claire posted a question. Somebody asked, are you also using AI for implementing your automation? And I'm going to be honest here, maybe embarrassingly honest, but I have never even considered using AI for automation, and it just kind of maybe a light bulb went off or something, but I'll have to think about that more later about what could potentially be done there. Ed, have you heard of using AI for automation in terms of CI/CD, or is it different type of automation?
So not on the CI/CD side, but on the AI ops and being able to use like machine learning to identify trends and patterns, and then also anomalies as well, and to help like correlate events. So there's something I was going to talk about more in the next session around how we can start incorporating machine learning and AI into your tool set here as well, especially with AI ops. So more to come on that in the next session. And I think gives us a good takeaway of seeing what are folks using AI in their CI and in their CD as well, and then be able to talk to that in the next session too.
Yep. I've definitely heard of it for documentation searches, where basically you point an AI bot at all of your documentation and kind of make a help desk out of it, where people are able to ask it questions then, and it pulls up the information that it's learned for you automatically based on that. Those are some cool things, but again, we'll get into that next time. So currently, I want to talk about containers. If you put your landing zone in place, we talked about that a lot during the second webinar about, preparing to go to the cloud and all the operational things you need to set up to get there. And, if you have your Terraform and your CI/CD, okay, you're ready to start actually moving your applications to the cloud now. However, your applications may not be ready for a truly cloud-native architecture using functions and microservices and all that. So this is where, in my mind, containers are a great way to quickly get you on the cloud and to quickly let you leverage some of those benefits of DR and HA and elastic scalability. Again, doesn't require a full replatforming or a full rewrite. So, on this slide are many reasons that your particular application may just not be a good fit for cloud native architecture yet, which is usually having to do with very, very tight coupling between different layers of the application. And really, the end state goal is to decouple as much as possible, so each is an individual component that could scale individually and fail individually even as well. If you want to go to the next slide.
So when we're talking about containers, I'm sure a lot of folks hopefully know this already, but what we're looking at is another layer of abstraction where we're now packaging the application and any dependencies and libraries together. So this is our nice package container, and it's sharing the same OS kernel as well. So this allows it to be much more portable, more efficient, and less expensive as well. So it's just an evolution of virtual machines. Now, as far as how to containerize your application, this could be a whole session on its own. We want to just spend a couple of minutes just talking through it at a high level. These are the steps that we go through with customers on how to containerize their applications. So we're looking at starting with choosing a base image, installing, obviously, then all the necessary packages and dependencies that they have, adding your custom files, defining the service account that you're going to use for it, exposing the ports that the application needs in order to be able to communicate, defining the entry points into your container, defining your configuration method, externalizing your data outside of the container as well, so that the container has a portability and the data is not stored on the data, allows it to be more ephemeral, and then how to manage your logs as well, and having the controls and the process in place for managing those. So this is, in a nutshell, the step-by-step. There'll be a link at the end of this on how to follow it too. If you had specific applications that you wanted to containerize, you can ping Rich and I afterwards, and we'd love to dig deeper into this. But in the takeaways, there'll be the step-by-step. Hopefully this gives a high enough overview for how to do so. Once you've got your application containerized, Rich, where do we go next?
So there's a few places you could actually go. This slide is about Docker and Kubernetes, but really quickly, I did want to mention that you actually can also go to Google's App Engine and use their flexible environment, and that's a really simplified version, let's say, of a Kubernetes type environment that automatically scales for you. But here we're mostly going to focus on the Kubernetes side and using GKE to help you achieve that same elastic scalability and high availability as well. So I just want to go, again, this is an entire webinar unto itself, definitely how Kubernetes works. I had to sit through 5 or 6 different lectures on it before it really started to click inside about how it works. The concept is very simple, but it gets complicated very quickly. And again, I'm just going to give a very high level overview that in Kubernetes, you have a master node and you have sub-host nodes, which are either VMs or physical machines themselves. But basically, this is the hardware you're running on, but it all gets completely abstracted away. And really, your master node is what controls where things get deployed and the amount of power you want to dedicate to each of your applications. So images, you need to create a Docker image. Think of a Docker image as an individual application component, or it could be an entire application itself. It really can be very, very small or very, very big. But the point is that it can be deployed in usually less than 30 seconds once you have that image due to the way that Docker works. So unlike a VM that might take you a few hours to re-image a machine, Docker can easily deploy and shut on and off these pieces to do whatever workloads you need, whether they're applications or if you're transferring a bunch of data from A to B, or it's a daily job. There's a lot there you could do. Pods are the smallest amount of think of it as a functional piece of Kubernetes, and at the highest level, what Kubernetes does is control multiple pods. Kubernetes is called a container orchestrator, is what it does. It controls between your hardware and between your definitions of how you would like your applications to run, and making sure the state of your applications is how you define it, but it's all behind the scenes. Go ahead to the next slide. So there's two ways of managing Kubernetes. One is self-managed, where, as we saw on the last slide, you can deploy it to your servers and make one a master and make multiple host nodes as you want. But this is really where the power of Google comes in, because, well, in self-managed Kubernetes, you're taking your environments and you're installing, you have a limited amount of power, and basically you're just running virtualized. Google allows you to scale it and add in more compute engines. And essentially behind the scenes, this is all virtual machines and compute engines, but it's taken care of for you. So Google can monitor when your compute engines are reaching thresholds based on CPU usage or memory, things like that. And it can automatically spin up and spin down servers for you that your workloads may need. So that's really the advantage.
I have a friend who told me, friends don't let friends manage Kubernetes. And that's why Google is here. So Kubernetes is extremely powerful, but also then like most extremely powerful things, pretty complex too. And that's where having Google manage it takes care, like it provides another layer of abstraction, and also peace of mind and SLAs that they provide around things like etcd and master uptime, that just helping take more off of your team's plate.
Absolutely. It can be daunting to manage, and it's amazing a lot of the technologies out there that have been started to develop to abstract away all that management, because people have realized how powerful these containers are, but again, how quickly they become complex to manage. And one of the technologies that's one of Google Cloud's most exciting technology that they've come out with in a while is Anthos. And this is a specific suite of tools and components designed to allow you to easily containerize your applications and move them to an environment that exists both on-prem and on multiple clouds as well. So the idea is, again, just get you to the cloud as quickly as possible to start taking advantage of those services. And really, like Terraform I was talking about earlier, where you can make one Terraform file and deploy it to AWS or Azure or GCP. Same thing that Anthos is trying to achieve. It's really trying to be cloud agnostic. And it is. It's pretty impressive how they do this. So here's some of the basic building blocks of Anthos. It's really a merging and melding of a lot of services that Google Cloud already provides. They provide a few additional ones to help you, and they've modified them to make this whole platform easier. So as we were talking about GKE before, GKE on-prem is another offering that Google has that obviously you install that on your on-prem servers, and it works seamlessly with your GKE in the cloud. It doesn't care which hardware it's running on between the two. It's deploying your workloads using your hardware for both. And like one of the companies that we've done some work for recently, they they decided to, again, throw money at a problem and just spend a lot more on their hardware. And I think they did, it was like a $10 or $20 million upgrade on their data center. And, but they want to start using the cloud like everyone else, but why do that when you just spent $10 or $20 million on your data center? This approach allows you to slowly move to the cloud, still use all that hardware that you have on-prem, and slowly, as you want to decommission it, get to the cloud to the future. So that's really the idea behind this. We're going to be talking about some of these other services a little bit more in depth later, like the Cloud Mesh and or the Anthos Service Mesh and Anthos Config Management. And Anthos Config Management is what allows us to really abstract away all of that hardware and all of that platform and allow you to seamlessly manage your configurations across all the clouds. Migrate for Anthos is that initial service to, again, help quickly get you all the steps that Ed mentioned in that previous slide. This is a tool set that helps you quickly detect and do all those things and create your configuration files, your Docker images to get you to the cloud. You go ahead, Ed. So I'm not going to dive into this too much, but at a high level, this is what an Anthos architecture would look like. Again, it abstracts away the abstracts away the hardware, and it allows you to observe everything that's going on below the system, and it makes updates based on that to your system in terms of hardware power and monitoring alerts and just optimizing and moving your workloads around. But again, I'm gonna leave this at a high level. The slide is complicated enough to look at.
We talked, Rich, about being able to use Anthos to help actually containerize your applications, and that's where this live migrate comes into play, right?
Yes, exactly. And this is the more detail on the live migrate is getting all those things that I mentioned in the first, returns your disks, taking your VMs. You can do that actually live and move all that stuff up to the cloud without any downtime at all. That's how smooth it is. That's how amazing they've really made this. It's just super cool technology that, again, their goal is to abstract away as much as possible to make this as easy for you as possible to achieve and get you to the cloud quickly.
I think a key thing here that I'll call out is a lot of what you see around containerizing and especially then here with Anthos as well is like it's only for Linux-based applications. So dealing with Microsoft ones is an entirely different ballgame. We're going to go into a little bit more detail on some of the tools and options available for that in the next session as well. But before then, so you've containerized your application. Hey, maybe it's running on Kubernetes now as well. Now we need to start digging deeper into the application and saying, all right, how do we start modernizing the various services within the application and the functionality it provides. So we've built our operational readiness foundation. We've containerized. We're now going to build a model for new microservices. So anytime somebody needs a new function, new service, some new functionality within the application, hey, we're going to have a model for building that as a microservice. So this is where we've got a repo for that. We've got pipelines, CI/CD pipelines, health checks, a template for building health checks into your application. Secret management as well is something that Rich and I talked about in the last session. We've got this for building new microservices. So anything net new is going to get built that way. But then we also need to look at what about some of the existing capabilities of our application? How do we start separating that out from the monolith? And it starts with identifying some of the simpler edge services as well. And then we can see really cost benefit, like which ones are maybe likely to be deprecated in the future versus which ones are core and maybe a little bit simpler, maybe already kind of small enough or segmented off that we can start to work with those ones. And then we're going to start strangling that monolith. This is where we're going to determine those distinct workloads and functions and peel them off as microservices one at a time. So either any new features, these green new features that I mentioned, like, hey, they can all get built with our microservice model, but then we're going to keep refactoring and replatforming those existing functions as new microservices as well. And as we do so, we start peeling them off, our monolith gets smaller and smaller, and hey, we've got more and more services now running. And then you start getting a new problem, and that's being able to manage services at scale, and that's where the service mesh comes into play. And we'll talk more about that in the next section as well. Being able to get to this is a nice place to get to where, all right, now we've killed off our monolith, and we've got teams responsible for their own services. They can deploy and manage their services whenever they need. They have the tooling with CI/CD to be able to do so. Now we need to make sure the services are aware of each other and can talk to each other. Anything else you'd add here around the strangling the monolith, Rich?
No, other than that, it's the right pattern. It's the right approach to go with for sure to get yourself to the cloud. It's again, thinking about for the long term, or to get yourself, I should say, not to the cloud. Hopefully you're already on the cloud through containers, but you could start peeling off some of those container workloads that make sense maybe to put in a more cloud native application architecture. But a lot of them can stay in containers as well for the ones that either just need something a little bit more custom, or are, there's nothing wrong with continuing to keep workloads on containers for the long term. And in some cases, that's the only option.
And then we go next is starting to build more API-based services as well.
Yep. So Apigee was a third-party product that Google purchased because it was so powerful. If you've heard of AWS API Gateway or Azure API Manager, Apigee is a very similar tool set, except it's that on steroids. It allows you to do so many different things related to APIs, including even monetizing them. So if you have a data set that you think is valuable out there that other people want to get a hold of, it literally provides you a mechanism to charge them based on how much data they're pulling, and allows them to, it handles all of that kind of e-commerce type ability for you in there. It's also extremely secure, but this again is where if you have an application that's on-prem, and let's say it's written in Node, one of the later versions, or Java, up-to-date version of Java, and you're already using a SPA, like a single-page application that's written in Angular or React, you could kind of skip that containerization phase and probably go right to something like this, designing your API gateway in the cloud to control all of your microservices in and out. And this is what allows, as Ed said before, to put a service mesh around this layer and to really start monitoring what goes in and out of it and how the connection points are made. Well, this does a great job kind of giving you controlling your pass-through and where things route. The next layer on really monitors point A to point B, point C to point D, and all across the way. So if we want to go on to the next slide.
Yeah, one of the things I love about Apigee is being able to insert it to add peace of mind and an additional layer of security and threat protection here as well. That's one of the ways that we use it with our applications and our customers' ones.
Yep. Again, it's a gateway to really protect everything behind it for sure. So I'm not going to go through all these, but it provides you a lot of services out of the box. The one I will call out here is the extensions under the mediation engine. So if you've used or heard of technologies like MuleSoft or maybe like Del Boomi, or basically integration platforms, this does provide an integration platform component, although I would still recommend using it purely for its API purposes and allowing other platforms to do some of that integration workload, but it does provide a great amount of integration services to quickly get APIs talking to each other if that's needed. That was one to highlight there as well. So we can go to the next slide. So how does Apigee fit? This is pretty simple. You know, at the top level is your consumers. At the mid-level, you're getting, Apigee is creating that secure layer. Underneath that is all of your microservices, and underneath that is really your data stores, your data lakes, and this is where like an enterprise service bus used to sit, because that would talk between all of your larger services, generally in service-oriented architecture, and move around that data as needed and collect it. But in the future, if we go forward, once you have, you go to the next slide, Ed. This is where you can stick in a real service mesh layer, and that's what the sorry, I can never pronounce this right. I'm going to make you do it, Ed, because it's Yep, Istio, yep. Which is really what Service Mesh is built on top of, but this is what does the tracking of all of your communications and your messaging, and it, along with using like a different messaging patterns like PubSub, you really understand which services are being leveraged the most, where your data is going, and if there's any problems, where the faults are. Anything to add on to this, Ed?
No, I think so once you've got your API-based services, we've talked about microservices as well here, and some of the benefits that I mentioned, where teams can now build, run, operate, and maintain their applications individually. So rather than, this is where we're moving away from the big bang quarterly releases that require 12, 24 hours of downtime, to the individual application teams can now run and operate their applications. And hey, if they've got a new feature that they want to push, they can be able to do so independent of the rest of the applications. And so this allows incredibly heightened agility, like much more reliability, and obviously more frequent, smaller changes as well. So as we start talking about microservices, Rich, what's some of the differences between like a microservices architecture and an SOA?
Yeah, and this is one of the topics I love to talk about, because so many people I run across, you know, say there's nothing new about microservices. This pattern's been around since the 60s, the 70s, the 80s. You know, we've done service-oriented architecture before. And I usually nod my head, because there's a lot of truth to that. But this is really the mindset shift when thinking the difference between service-oriented architecture and microservices, which fit a lot better into the cloud. So microservices is all about decoupling. Get your individual components, you know, as small as they possibly can, and make sure they do not rely on each other as much as possible. SOA is more about just making sure your functionality, that the services are reused for each of their individual purposes, get rid of as much duplicated code. So here, again, in code reuse, microservices, we say copying and pasting is okay, because you know what? If you have two different services that are using the same code base, they're really the same service at this point. And when you update the code for one of them, you have now updated the code for the other one, and you have that dependency, and that's what we're trying to avoid there. So asynchronous messaging and a few, just really quick, and I know we're running out of time. Data duplication, it's okay using microservices, so you never want that. And again, the size there is, you know, micro versus small. So go ahead, Ed. You can go forward now.
Yeah, that's great, Rich. And then here's some microservice examples as well of like different services running independently, but maybe like sort of grouped together. And really cool is, as you start to expand your microservice journey, this is where, hey, you can start maturing, and where we have like a maturity path for you on that journey. So, hey, you've started to separate out your services, and these are maybe pretty simple. But they might be insecure, low reliability. That's where things like Apigee can come into play as well. And then now you want to start moving up the model with being more elastic, providing like managed Elastic services as well with API management capabilities, and then like again with Apogee coming into play here too, Rich.
Oh yeah, for sure. Apogee really allows you to take yourself from a small level to grow to that small level of microservices. So or grow to that mature level of having mature microservices that are again completely managed, completely elastic. They're cloud native, API enabled. We could go to the next slide.
How do we manage?
Keep looking at the clock.
how do we manage queues and then talking to each other?
Yep. So this is where messaging comes into play. And again, this is another one where this is a webinar unto itself. But you have all these little small components. Now you have to decide how are they going to talk to each other. And there is a dozen different ways to design this. And usually where some of the more passionate arguments or passionate design approaches, I should say, and differences I've seen come into play with a lot of people. So basically, there's a lot of different factors that you could take into place. And this is really going to establish the backbone of sometimes if you're just building a small application, what that application looks like, or even thinking about the larger of your, again, enterprise architecture of how your application is going to communicate with other applications and how easy that's going to be. So you could take the small view, you could take the big view, you could take some easier paths, you could take some more complicated paths that provide you there. If you go on to the next slide, so these are just a few of the considerations of how, when you're deciding on how to design your messaging architecture, there are a number of patterns out there. There's a number of technologies for different services or for different types. There's just a number of principles that you have to take into consideration, like domain-driven design, and maybe if you want to go with event-driven architecture and event sourcing. Again, this is really getting to deep application level type work. Really quick, I wanted to shout out to CQRS. This is one of my favorite patterns. I will admit that it's probably one of the more complicated patterns, but it gives you a lot of power in terms of being able to replay every single thing that happened in the past, however long your memory holds out to, and get yourself back into any state that you want. But you could think of your applications, as we know, as every single thing is an event. So capturing all those events and having a log and secrets of every single thing a user does, allowing it to control where your applications are and the state of your applications is a powerful pattern. You go, Anna. Your operations.
Yeah, with all those events and capturing, managing all the events is very then easy to be able to set up the monitoring and logging around them as well, so you know exactly when and where there was a constraint or an issue. So we've covered previously some of the best practices around setting up monitoring, best practices around setting up logging as well, especially as you move to this microservices container-based model, getting standard out, standard error into like an aggregated login system. We looked previously in the last session at Google's Stack Driver, what is now Google Operations, and how that can help you hit the ground running with both of these. I'm a real site reliability engineer nerd, so I love service level objectives and SLIs. In the last session, we talked about how to set up SLIs around some low-hanging fruit with your application availability and application latency as well. There's some links in the takeaways on how to set these up too. And then in the last session, we talked a little bit about incident management. And specifically, we looked at how to integrate your monitoring with Google Operations into ServiceNow and then into like a paging system like Xmaster. So we covered this in the last session. Now in this session, taking it to the next level, we're also going to layer on logging and then also outputting to chat as well. So in this case, Slack. So one of the things that we identified as we work with more and more customers spinning up workloads in cloud is like the monitoring metrics themselves isn't enough, and especially in the application world. So we wanted to start looking at how do we create alerts and incidents off of logs, off of container logs, off of application logs. We've got a very simple example here where we've got a null pointer exception. It's coming through in the logs here. We can create a metric. So this is Google Stackdriver, what is now Operations, where we can create a metric around with this filter. So anytime we get a null pointer exception, hey, it's going to create an incident. And then with the ServiceNow integration that we'd previously built, it's now going to create a ticket for somebody to work in ServiceNow. And hey, if it's high enough priority and it's creating an outage, like, hey, it's going to page out as well. We also, a lot of our customers are heavy users of Slack and Microsoft Teams. So we love to output stuff and follow this model of chat ops. So Stackdriver has an integration into Slack. It's very, very easy to set up. And as you can see here, we've got a couple of different ones. We've got ServiceNow integrated into Slack so we can see when new stuff is hitting the team. And then we've also got our incidents from Stackdriver coming into Slack as well. So these are two nice low-hanging fruit iterations of setting up your incident management. So that concludes our third webinar in the series, getting you there to containerizing and modernizing your applications. There's still a lot more that you can do thereafter, and that's where the next webinar is coming into play as well.
Absolutely. And really quick, and I just want to give people that overview of kind of the full journey where we go now that we've shot it at them very quickly. Their brains are all hurting. But, again, start out with that infrastructure modernization, infrastructure as code. Then after that, get your CI/CD pipelines in place. That'll save you all the time in the world when redeploying your applications as you make your updates. Start using containers. For especially any monolithic applications that you have or applications that just aren't going to fit easily into that microservice architecture, use Kubernetes and GKE to really scale, be able to quickly scale those monolithic applications and give them the additional power that they need to using the power of the cloud, or even take them down and save yourself money if you're currently having a monolithic application that's not running on a big piece of hardware that it just doesn't need to be running on. From there, use like a strangler pattern like I talked about, start peeling away those services from your Docker images and your workloads running in containers and putting them into maybe something like Cloud Functions more, or even just peeling them away and putting them in smaller containers, but to really decouple and break them down. For managing it, once you're there, you need to have your API gateway services and your messaging bus for how they communicate. And obviously, as I talked, you want to operationalize all that so you have a solid view into what that looks like. So just wanted to take you through the whole sequence again so it kind of makes sense in terms of a path of what we've covered today. Go ahead.
Perfect. So there's some takeaways at the end of the deck. The entire session was recorded. The deck will be sent out as well. Rich and I are available. Afterwards, if you have questions, you can stay on, or you can ping us on the emails here as well. And Colleen, I guess I'll let you see us out.
Yes, thanks, Ed, and thanks, Rich. Great session, great recap there at the end. Thank you, everyone, for joining today. A question in the chat about the gift credit, the Grubhub credit coming. We will get that out to you all by Friday morning. So Friday morning, you can expect to receive emails from us with the recording to this, the PowerPoint slides, and then your Grubhub credit to use for lunch in the future. Also want to remind you all, like they said, our next session, August 19th, is our fourth and final session. Once this webinar closes out today, you'll get a survey that pops up into your browser, a little WebEx survey asking you how you enjoyed today's session. Please feel free to leave us a comment there if there's other specific items you'd like to see us cover on this modernization roadmap journey. We're going to continue this discussion in session 4, and if you have specific things you want to see us deep dive into, we would love to customize the session for you all. So please check that survey out and give us some feedback there. And then, as usual, Rich and Ed's emails are up on the screen here. Please shoot them a direct note if you have any questions about your organization or specific things. I know they'd love to chat more. So with that, we will close out for today. Thank you again, Ed and Rich. Thanks everyone for joining us, and have a great afternoon, everyone. Talk to you soon.